Greetings, chemistry students. Today we are going to learn how to determine what kind of reaction we're going to have just by looking at our reactants. So this is going to help us to predict products. So what that means is that when you see that we're mixing two reactants together, we're going to be able to predict what our products are going to be, exactly what it is that we get out of that mixture. So you can follow along with me in your packet. We are going to learn first the general forms of each reaction type, and then I have examples to do for you, and then you will be ready to watch our demos and to try this on your own later on. But if you take a look at the top of the page, any letter is going to firstly represent an element or a polyatomic ion. So if you just see the letter A, then that's going to be an element. But like in the second bullet point, if you see the letters C and D together without a plus sign in between them, that means that that is a compound. And this is an important piece as well. The first letter in any compound is a cation. It always has a positive charge, while the second letter in the compound is the anion, and it's going to have a negative charge. Remember that you have to determine the charges of each of the elements that are in a compound in order to figure out the correct formula for that compound. So you have to do your crisscross applesauce trick. The last thing that I really want to impress upon you and that I've repeated multiple times in class is the diatomic elements. Here they are listed for you here. So remember that when they stand alone, you have to have a subscript of 2. When they are bonded to another element in a compound, then you don't have to have a subscript of 2. You have to do crisscross applesauce to figure out what the subscript is. Okay, so if you need a moment to read through all of those bullets again, put this on pause and do that. But if you're good, then let's get started. Okay. So the very first reaction example that we see here is A plus B yields AB. And so what we have here are we have two elements become one compound. We call this kind of reaction a synthesis reaction. So two things become one thing. Sometimes you can even have two compounds joining up, but your product is always going to be one. So if you start out with multiples and you end up with one, then that means that you have a synthesis reaction. Now, the opposite of this reaction is called a decomposition reaction. In this reaction, a compound falls apart. So we have one compound becomes either two compounds or two elements, but it falls apart into multiple pieces. So I'm just going to say two elements here. And so these two are opposites. So that's synthesis and decomposition. Okay, in our next one, which I'm just going to put a red arrow by the top one, what's going to happen here is that A is a metal and it is going to replace C, which is the cation or the metal in the compound here. So if A is a metal, it replaces the metal. And what we get is AD combine and C is left out in the cold. So when A replaces C, that means A is positive, and this is what we get. So basically, in our top equation, which I'll write in red, basically one metal replaces another. But in blue, let's take a look at the other one that's very similar. The difference is that here A is negative. So now A isn't going to replace C. A is going to replace the anion or the nonmetal D. And so in the blue equation, we have one nonmetal replaces another. And so in the blue equation, D has been displaced. D has been kicked out and is now left on its own. So what we have here for both of these, this is called single replacement. And the way that I like to think about it is that one element that was alone now is a part of a group, and a different element is now left out in the cold. Moving on to our next one, let's pick a different color here. Now what happens here is that our metals or our cations are going to switch places. So if we look at our reactants, A and C are going to swap places, and we end up with two new compounds. So with this kind of reaction, we have two compounds become two new compounds. Basically, the metals swap. This is called double replacement. Again, this is different from single replacement because in single replacement, one element is always left by itself. But in double replacement, you still have compounds. They're just different on the left and on the right side of the arrow. Okay. And then in our very last equation that we have here, you're going to notice something different. We have C with the subscript of X and H with the subscript of Y. This is called a hydrocarbon. Because it's only made of hydrogen and carbon, hence the name, hydrocarbon. So it's made of only hydrogen and carbon. So if you see that, that's your first clue. Now you're probably wondering, well, what's the X and what's the Y? Well, from algebra, you should know that those are variables. Hydrocarbons can be as small as CH4, like here's a hydrocarbon. You could have C8H20, or I'm sorry, CH8, not 20, CH818. You could have C200, H202. So these hydrocarbons can get pretty large. So because of that, when we start balancing them, there's a little trick that I'm going to show you so that you can always get the right answer. That's the beauty of that trick. Anyway, so in a combustion reaction, that's what this is, combustion. Whoops. In a combustion reaction, you have a hydrocarbon that's being burned in the presence of oxygen. So the products that you get when something burns cleanly, when something burns completely, is carbon dioxide and water. So when you look at an equation, you're like, I don't know what kind this is. You need to first look and see, do I have a hydrocarbon? And if so, look and double check, do I have carbon dioxide and water as my products? Then yes, this is a combustion reaction. So those are the clues to look for. Hydrocarbon as one of the reactants, as well as water. And carbon dioxide and water are always the products. Okay, I'm going to stop this video here and then I'm going to do another video to show you how to use these notes in order to determine what kind of reaction we have, and also just how to predict what some of the products are. Okay, I'll see you soon.